this is a lesson on some more hyperbolic functions. So more hyperbolic functions. More hyperbolic functions. Okay. Right, before we do any of that, let's just have a little recap. So we'll do a recap. Okay, you should know, hopefully, that sec x is the same thing as 1 over cosine x. Okay, so sec x is 1 over cosine x. Cosec x is 1 over sine x. And cot x equals 1 over tan x. Okay, so we should know those as the different alternative trig ratios. Okay, so you may well have guessed what's happening now, but I'm going to say it anyway. What we're going to now is we're going to define. So we're going to define the hyperbolic sech to be 1 over the hyperbolic cosine. So sech x is 1 over cosh x. This is where it starts to get really hard to say. Cosech x. So cosech x. Well, that would be 1 over hyperbolic sine. And coth, C-O-T-H, coth x is going to be 1 over hyperbolic tangent x. Okay, so those are going to be the definitions that we're going to think about. So in terms of exponentials, 1 over cosine, 1 over cosh would be 1 over e to the x plus e to the minus x over 2. So if I simplify the fraction, I'm going to end up with 2 over e to the x plus e to the minus x. So sech x is equal to 2 over e to the x plus e to the minus x. Likewise, cosech x, well, it would be almost the same here, except we have a minus here, so it's going to be a minus here. So that would be cosech x equals 2 over e to the x minus e to the minus x. And finally, coth x will be 1 over tan x. So that would be 1 over e to the x minus e to the minus x over e to the x plus e to the minus x. So that's saying that coth x is equal to e to the x plus e to the minus x over e to the x minus e to the minus x. And you might realize that that's the same thing as cosh x over hyperbolic sine. Okay, so essentially what we've done is we've replaced, in simple terms, we've kind of just added a h to everything. And we turn everything, all we've done is we've said that the same for hyperbolic. Okay. For the definition, that's why we've motivated the definition. Okay, so now I'm going to look at the graphs of each of these. I'm not going to look at the inverses for this lesson, but I'm just going to go for the basic graphs of sech, cosech, coth. Okay. So let's start with sech. So we've got y equals, let me write it over here actually. Suppose I want to graph y equals sech x. Right. Anytime you're looking at drawing a graph of something like this, until you remember them all off the top of your head, and to be honest, I find that tricky, it's always a good idea to think about, well, how does this relate to the one that we already know? So we know that this is going to be 1 over cosh x, isn't it? So let's draw a quick sketch of cosh again. Okay, so it's like a curve, it's going to come up here, so 1 x y. So sech x is going to be 1 over cosh x. So what we're going to do now is I'm going to look at this graph now. I'm going to divide by the values on the blue line, so you'll see. Okay, so there's one fixed point, so I'll do this in green now. If you notice here, this is 1. Well, if I do 1 divided by 1, I'm still going to get 1. Okay, so I'm still going to get 1. 1 is going to be a point that's on both graphs. The point 0, 1 is on both graphs. So the point 0, 1 is on both. Hopefully you can see that's obvious. Now then, what we're going to do is we're going to 1 divided by the value that is cosh. And the value that is cosh is the blue line here, the blue curve. So this is cosh x. So only 1 divided by this. But as you can see, this is dividing by a positive number that's increasing. So what's going to happen is, as you divide by a bigger and bigger number, your answer is going to get smaller. It's never going to reach 0, though. No matter how big a number you divide 1 by, the answer is never 0. So what's going to happen is it's going to come down like this. Oops. It's going to come down like this. But it's not going to look like first. That's never going to rise. So it's going to come down like this, and then it's going to have an asymptote going that way. Likewise, as we're dividing by 1 divided by these values here, notice that this is going to get a really big number. It's going to come down this way. We'll try and do it a little bit better. So all I'm saying here is, if I take a point here and do 1 divided by that value, it's going to get smaller and smaller, isn't it? So this is the graph of y equals sech x. Okay. So the point on it here is 1. Okay, it's probably worthwhile having a look at how we might look at this from an exponential point of view. So I will write that now. The definition of sech x is equal to 2 over e to the x plus e to the minus x. So if we think about this way, so as x tends to positive infinity, so as x goes this way, large, what's going to happen to e to the x? Well, e to the x is going to get large. As x gets large, e to the x gets large. So that's going to go to positive infinity. What about e to the minus x? Well, as x gets large, e to the minus x tends to 0. Okay, for large x, if you think about the graph, I'll put another graph on here just as a quick sketch. This should be really in your brain, not this one by now. Let's do an e to the x very quickly. It's going to look something like that. So as x gets large, e to the x gets large. Okay, as x gets negative and large, e to the x tends to 0. So if we look at combining these facts here, this term here will go to 0. So this term here will go to 0. This term here will get very large. Doesn't ever equal infinity because infinity is not a number, but it's going to get large. So when I divide 2 by a larger number, it's going to go towards 0. So this has an asymptote, doesn't it? There's an asymptote and that's going to be the line y equals 0. So that's a basic graph of sech, hyperbolic secant. Okay. Also, probably want to mention that this value, the domain, the values that you can put in the domain, well, this is true. This can be valid for all x. We can put any real number, or alternatively, x is a real number. Okay, so we can put any value in and get a sensible answer out. It's not gonna blow up anywhere. Okay, so next one. Let's have a look at cosech. Okay, so let's have a look at y equals cosech. Okay, so again, whenever we've got we want to think about a graph of something like y equals cosech, think about the graphics based on. Well, this is based on it's 1 over the hyperbolic sine, isn't it? So this is the same thing as y equals 1 over hyperbolic sine. So let's have a quick sketch of that just to remind ourselves. Hyperbolic sine kind of comes up a bit like a cubic, does something a bit like that, doesn't turn back on itself. So it goes through the origin anyway. So this is y equals hyperbolic sine x. Okay, fair enough. So how's that going to help us with the graph? Well, let's have an axis. Okay, well, first thing we probably should think about is at 0, when hyperbolic sine is 0, and it does go through the origin, 1 over 0 is not defined. So, 1 divided by 0 is simply not defined. But as we get close to 0, we're going to go really large, aren't we? Okay, so this is going to have, it's going to get, as we divide by smaller numbers, the answer will get larger. So it's going to come up like this. Okay. As we divide by ever larger numbers, the answer is going to get smaller and close to 0. So it's going to look a little bit like that. Maybe it'll be a bit more, it's kind of be quite steep down because exponentials grow really fast. Okay. On the flip side, it's going to be the exact same reflection. As we divide by a large negative number, the answer is going to get very small but negative. Okay, so it's going to come up and do something like that. Okay, so this is going to be the graph of y equals cosech x. Okay, so this has got an asymptote, hasn't it, at x equals 0. So there's an asymptote x equals 0. So actually, when we're thinking about the function cosech x, x cannot be 0. So x is a real number, but x cannot be 0. Okay, because if we did, then we would be blowing up. Okay, how might this look if we try to consider it just with the exponentials, just for completeness? So if we recall that we're going to end up with cosech x would be 2 over e to the x minus e to the minus x. So as x tends to infinity, positive, as x goes to the right, gets large to the right, what's going to happen? So we know that e to the x will get arbitrarily larger, it will get massive. E to the minus x, well, that will tend to 0. Okay, so what's going to happen? So as we go to the right, this term here will go to 0. This term here will go to positive infinity. And so the whole thing will collapse down to 0. Okay. What about the asymptote? Well, e to the 0 is equal to e to the minus 0, and they're both equal to 1. So if x was 0, this would be 1 minus 1, which is 0. This would be 2 divided by 0, and so it would blow up. And again, you can do a similar reasoning for the case where x goes to negative infinity. Okay, what will happen then is this term will go to 0, and this one will go arbitrarily large, but it will be negative. And so we end up with our graphs. Okay, let's think about the last case then. The last case would be Coth. So suppose we was going to draw y equals Coth x. So again, we want to be thinking about, every time we've got one of these, we should think about drawing this sketch of the one it's related to. So hopefully you'll remember that Coth is the same thing as 1 over hyperbolic tangent. So this is related to 1 over the hyperbolic tangent of x. So perhaps we should sketch that first. Well, the hyperbolic tangent has an asymptote at 1 and an asymptote at minus 1. And it's going to come and get closer and closer. It's going to go through 0 and closer to 1. Okay, so there's the graph of hyperbolic tangent. Okay, so I've done the hyperbolic tangent graph there. So let's get ourselves a graph ready to draw the hyperbolic Coth, or Coth. It's hard to say these things. Okay, so again, let's go for an easy win here. There's going to be an asymptote at x equals 0. So as we go towards 0, our graph is going to get larger and larger. Okay, because we can't divide by 0, but as we divide by smaller numbers, we're going to get a larger and larger answer. Okay. As we go this way, though, the number that we're dividing by is going to get close to 1. Can we see that? It's going to get close to 1. So in a sense, this is not going to be 1 divided by a number close to 1. Well, what's that? That's going to be 1, isn't it? Okay, so we've got the idea of the division is going to get close to 1 because it's going to be 1 divided by a number close to 1. So that's going to be an answer roughly 1. And as we go closer to 0, it's going to get larger and larger. So it's going to end up with this kind of shape. And something similar will happen on the other side. So we're going to have an asymptote this time at 1 and minus 1 as before. Okay, so this is minus 1, this is 1, the origin. As we get large, the division becomes close to 1. So it's going to kind of do that. Okay, and let me make this graph a little bit bigger. Alternatively, I'll just put this in a better place. Okay. There we go. And now what we're going to do is we're going to have this come this way. Okay, so what's happening here is that the graph, as I say, as we go this way, we're divided by a number close to 1. So 1 divided by a number close to 1 is 1, roughly. And as we come this way, get close to 0, we're divided by large numbers, small numbers, sorry, which makes the result of the division really big. And likewise on the other side. So we end up with this kind of almost a bit like a hyperbola. It's going to kind of come up like this, and it's going to come down like this. So again, we probably should think of this in terms of exponentials and see how that bears out. So I'm going to do that now. So if I was going to do this in exponentials, well, Coth x is e to the x plus e to the minus x, all divided by e to the x minus e to the minus x. It's not terribly easy to see there what's happening. So what I'm going to do is I'm going to times everything by e to the x and get e to the 2x plus 1 over e to the 2x minus 1. So now, as x tends to infinity, positive infinity, well, these two numbers are going to get near enough the same number. Like 1,000,001 and 1,000,000 are very close. 1,000,001 and 1,000,000,000 are very close. So when we divide them, this answer is going to get close to 1. So in other words, coth x will go towards 1. On the flip side, as x tends to negative infinity, or as x tends to 0, sorry, as x tends to 0, well, this will become e to the 0. This will become e to the 0, but 1, this e to the 0 is 1, so e to the 2x becomes close to 1. So as x tends to 0, e to the 2x becomes close to 1, and so 1 minus 1, well, that's undefined, isn't it? So essentially this is going to explode. It's going to get larger and larger. So that's a review of the three graphs. I just mentioned here that this is an asymptote at y equals 1 and y equals minus 1, and also that this is okay, coth is okay, its domain. X can be a real number, so x is contained in the real numbers, but x is not 0. Okay, so let's quickly look at them all again. So we've got, there's our basic definitions. Sech is 1 over cosh, cosech is 1 over hyperbolic sine, coth is 1 over tanth. Some people say shine and fan, which I just don't do. So there's the graph of cosech. It looks a bit like a hyperbola. We've got an asymptote at x equals 0. It's true, its domain is any real number apart from 0. Next one. We've done that one. So we've done. Okay, this one here. Sech. As x gets really large, then this goes close to 0. As x gets negative large, it goes 0 the other way, goes through 1. And we've just done tan. Okay, I'm going to conclude the video there. I'll do the inverses separately on a different video.